Let me know whether this screen is visible. Is this screen visible to all?
Sir.
Yes, visible, right? Thank you. So quickly let us run through whatever we have done yesterday. First, the definition. Then we have come across, let me use darker pen. So then Z-transform, and there is also inverse Z-transform, and value of Z, it is R into e to the power j omega. Then right-sided sequence, left-sided and double-sided sequence. We have found the Z-transform of right-sided sequence and its ROC, which will converge for all Z but not Z is equal to 0. Then left-sided sequence, this one is left-sided sequence, converges ROC for all but not for infinity. Okay. Then double-sided sequence, ROC will be existing for all the values except 0 and infinity. Then we have seen a to the power n u of n. For this we have calculated what is the Z transform. I hope you remember these points. Okay, let us now go further, and I wanted to show you the ROC again. So as I have said, I'm audible, right?
Yes, sir.
Okay. Thank you. Now this ROC is magnitude of Z greater than A. So region of convergence in this plane. Give me some time. In this plane, okay, there is some point A. Beyond this point, our Z transform will converge. That means it is outside this circle. The radius of this circle is A. What is this A? A is here in this equation. If you substitute Z is equal to A minus A will be 0. A divided by A minus A, that is A divided by 0 you will get if you substitute Z is equal to A. Then what will happen? X of Z will tend to infinity. Okay, that is the meaning of this equation. So Z should be greater than A, then only we get a right-sided sequence, that is Z transform of right-sided sequence. Okay, magnitude of Z greater than A, then only we'll get the right-sided sequence. So outside this pole, we call this as a pole. Whatever value which makes X of Z infinity, that value we call as a pole, whereas whatever value which makes X of Z as 0, we call it as a 0. 0 0 ನೇ ಹೇಳ್ತೀವಿ, ಆದರೆ ಇನ್ಫಿನಿಟಿಗೆ ಯಾವ ವ್ಯಾಲ್ಯೂ ಇಂದ ಇನ್ಫಿನಿಟಿ ಬರುತ್ತೆ ಎಕ್ಸ್ ಆಫ್ ಝೆಡ್, ಆ ವ್ಯಾಲ್ಯೂನ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ, ಇಟ್ ಈಸ್ ಎ ಪೋಲ್. ಓಕೆ, ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದಟ್ first. Here the equation say z of z minus 1 divided by z minus 2 z minus 3. This is my x of z. Okay, example. I just wanted to clear your doubts about poles and zeros, then we can move further, that's why. So in this equation, what value z can take so that x of z goes to 0? Let me know if anyone understood this. What values of z will make x of z 0? That we need to see first. What are the values of z? You want to make x of z is equal to 0. Either you substitute z is equal to 0 or you substitute z is equal to 1. What will happen? This entire term will become 0. 0 by anything will be 0. So 0 and 1, z is equal to 0 and 1 are called as zeros of the x of z or z transform for the given sequence. I hope it's clear. Zeros. Now what value of z makes x of z infinity? If you substitute either z is equal to 2 or z is equal to 3, 2 minus 2 will be 0. That is 1 by you can say any value z minus z into z minus 1 divided by 0. 1 by 0 will be infinity. Or if you substitute z is equal to 3, then also you will get infinity. Or if you substitute both z is equal to 2 and 3, you will get infinity. That means this z is equal to 2 and 3 are called as poles. Okay, these are poles. That is numerator and denominator. For poles you have to look at denominator. For zeros you have to look at numerator. Is that clear? Pole zero concept. Please let me know. You can turn on your mic and just let me know how much you have understood. If you have any doubt also, you can ask. Is that clear? So here for this one there is 1 0 and 1 pole. 0 at z is equal to 0. 0 is here. Okay, and pole is here at A. Okay, and your ROC will be outside this A. Magnitude A, it is not a only A. Plus A alla idu magnitude of A. Always it is a circle with radius A. Okay, so this is how we need to understand ROC or region of convergence for a given signal. Okay, we'll move further and we'll have a look on the different. This one let me complete. Okay, this is A, one pole, and this is a 0, and this is your ROC outside this pole. Real axis of z, and this is imaginary of z. Okay, this is clear, right? This problem is clear. Now let us move on to the second problem. That is third one. Here the second one, negative time exponential sequence. Let me copy the sequence first. Second one we have is, first one is positive time exponential, second one is negative time exponential. So whatever Z transforms I am discussing now, they are called as standard Z transforms. Remember that. They are the standard Z transforms. In this, x of n given is equal to, x of n is equal to b to the power n u of minus n minus 1. Okay, earlier for positive sequence we had x of n is equal to a n u of n. Remember this. You are not writing u of minus n, you are writing minus n minus 1, because u of n included n is equal to 0. It has included n is equal to 0 also. Okay, that's why leaving that out, whatever left is our left sided sequence. 0 na ನಾವು right sided sequence ಅಲ್ಲಿ include ಮಾಡಿರೋದ್ರಿಂದ what we are saying, from 1 n is equal to minus 1, minus 2, minus 3, like that. This is the sequence minus infinity till minus infinity. This is the sequence we call it as minus n minus 1. Minus n ಅಂದಿದ್ರೆ n is equal to 0 ಇಂದ minus infinity ವರೆಗೂ ಇರ್ತಾ ಇತ್ತು. ಇವಾಗ ಹೇಳ್ತಾ ಇರೋದು ನಾವೇನು minus n minus 1, because n is equal to 0 term is included in the right sided sequence. That's why we cannot include that in the left sided sequence. So that's why I am taking this as a u of minus n minus 1. Okay, and another term I missed is, it is we have considered this as a minus of bn, not plus. So minus of bn u of minus n minus 1. This is a standard sequence, negative sided sequence. Okay, why it is standard I will let you know when we get the final result of this. So first what we have to do, we need to understand what is this sequence. Okay, the limits of this sequence, then we can simplify it for x of z. So let us write equation of x of z first. X of z is equal to summation n is equal to minus infinity to plus infinity x of n z to the power minus n. Okay, in this we have summation n is equal to minus infinity to plus infinity. What is x of n? Minus of bn u of minus n minus 1 z to the power minus n. This is the value when we put x of n in the equation. Okay, now what is u of minus n minus 1? You know that this is, let me start from here. This is your u of n. Okay, when I say u of minus n, you will write correct. This is n is equal to 0 to minus 1, minus 2, minus 3 up to minus infinity. This is your u of minus n. Then next target what I am giving is u of minus n minus 1. Already I have told minus n minus 1 means it is the left shift. Correct? It is the left shift. So we will get sequence starting from here. Minus 1, minus 2, minus 3, minus 4, and here it is 0. Give me a second. So this is at 0. So this sequence I will call as u of minus n minus 1. And what are the limits of this sequence? Limits of this sequence. But u of minus n minus 1 is equal to 1 for what values? It is 1 for what values? Please look at the diagram and let me know.
Minus 1 to infinity. Minus
Yes,
infinity.
minus infinity to minus 1, reverse.
Yes.
From minus infinity to minus 1. So from n less than or equal to minus infinity less than or equal to minus 1. For these values of n, this function is having a value of 1. So we can change, because other values if you multiply minus b power n also, it will become 0. So it is useless to multiply and keep n is equal to minus infinity to plus infinity. That's why what we will do now, we will change the limits. So change the limits, that is n is equal to minus infinity to minus 1 minus bn z power minus n. I think this is clear now. Correct? So this is minus infinity to minus n. Now let me simplify this further by considering let let me consider m is equal to minus n. M is equal to minus n. Okay. After substituting wherever m is there, I will substitute as a, sorry, wherever minus n is there, I will substitute it as a m. This implies n is equal to minus m, and n is equal to minus infinity means m is equal to plus infinity, n is equal to minus 1 means m is equal to plus 1. Is that clear? So this implies x of z is equal to m equal to 1 to infinity minus of b minus m z plus m. This is what we'll get, correct? I've just substituted m is equal to minus n. Okay. Now m is equal to 1 to infinity. This is somewhat what we can say is tricky. Here what we have to do is we have a formula, that is m is equal to 0 to infinity a to the power n means we can directly write 1 divided by 1 minus a. This you know. But here it is from 1 to infinity. 1 to infinity. In this kind of situation, what we actually do is we will consider this equation as 1 minus summation m is equal to 0 to infinity minus of bm z to the power minus m. If I substitute m is equal to 0 in this equation, what will happen? 1 minus 1 plus this summation m is equal to 1 to infinity minus bm z minus, sorry, minus, here it is minus m plus m minus m plus m. Okay, so this 1 and 1 will cancel out. So it is same. This equation is same as this equation. Okay. That's why what I will do, I will write it as a 1 minus summation m is equal to 0 to infinity minus of z m. This is what I will write. Okay. Now this 1 will be remaining same. This I will rewrite as m is equal to 0 to infinity b to the power minus 1 z to the power m. I hope you understood this step. Now 1 minus 1 divided by 1 minus b inverse z. This is what we get. So this is nothing but 1 minus 1 divided by 1 minus z by b. Okay. Now let me cross multiply this. 1 minus b divided by b minus z. Correct? Now this b minus z I will place here, minus z minus b divided by b minus z. Okay. So plus and minus will cancel out. This one will be minus z divided by b minus z. Instead of this, what I will write is minus I will take as common z minus b, minus of minus and minus will cancel out. You will get z divided by z minus b. Okay, this is x of z for the given sequence. This is x of z for the given sequence. What was the sequence? Minus bn u of minus n minus 1. This was x of n, and for that this is our x of z. And what about ROC? Region of convergence is this b inverse z is less than 1. That means z by b is less than 1, or z is less than b. This is the condition, right, for ROC. B inverse z, this term should be less than 1. Okay, earlier also we have seen this. Here a z inverse is less than 1. This term is less than 1, correct? For this equation it will be b inverse z here. B inverse z is less than 1. That means z is less than b. So what is the meaning of this? If I draw the ROC of this signal, the ROC of this signal is like this. If this is a pole B, ROC is inside this circle because it is left sided, left to the B value, correct? B is here, left to the B is your ROC. This is real axis of the Z and imaginary axis of the Z. So this is your ROC. Earlier ROC for the right sided sequence was like this, outside. Now for a left sided sequence it is inside. Any doubt regarding this? I hope I am clear with the concept now. Any doubt? If you have, you can ask, please. Okay. So here you can again revisit whatever I have explained. Okay, only thing I forgot to mention was this is called as z plane. Okay, z plane, in that we have imaginary and real axis, and ROC is denoted by this circle, which is inside the circle region of convergence for a left-sided sequence, standard sequence. Okay, now for two-sided sequence we need to just combine whatever we have learned in both the cases. Okay, let me clear again here. You can see x of z is positive, correct? X of z is positive here for x of n is equal to minus b power n u of minus n minus 1. Here we had minus, still we are getting positive here. Remember this. If at all some problem is given like this, x of n is equal to bn u of minus n minus 1, then the answer would be minus of z divided by z minus b. This is the difference. Okay, for x of n, if here it is a minus for a negative sequence, here it is a minus, then you will get a plus here. If you are getting a plus here, then z transform would be multiplied by minus because of the symmetry itself. Here x of n is minus of bn and x of z is this. If you want for this one, it will be minus of xn. Okay, so this point you need to remember. So let me write these three relations now. X of n is equal to an u of n. For this you will get z transform as z divided by z minus a, and ROC is magnitude of z is greater than a. Second one, x of n is equal to minus bn u of n, sorry, u of minus n minus 1. U of minus n minus 1. For this, z transform is z divided by z minus b. Both are positive. Output here positive and positive. But only thing is ROC is b. That is z is less than b. This is point A. And here ROC will be inside this point B. Okay. Now, if at all x of n is equal to b power n u of minus n minus 1, then this will become minus z divided by z minus b. Okay, this is the difference. Here minus is there, then it will be plus. Here plus is there, you will get a minus. Similarly, if we have a minus here, then we will get a minus here. I hope it's clear. These are the three things we have learned. Now it is interesting to note that two-sided sequence will have, when I say two-sided sequence, it will have both positive side as well as a negative side. So given x of n is equal to an u of n minus bn u of minus n minus 1. This is a two-sided sequence. For this is third problem, very very important, double-sided sequence. For this one, we need to find what is x of z. So can anyone tell what is, already we know the answer. First we have to apply the equation. X of z is equal to summation n is equal to minus infinity to plus infinity x of n z power minus n. Now let me substitute for x of n. So what we'll get? N is equal to minus infinity to plus infinity an u of n minus bn u of minus n minus 1 multiplied by z power minus n. Okay. Now individually, after separating the brackets, what I can get is n is equal to minus infinity to plus infinity a power n u of n z power minus n minus summation bn u of minus n minus 1 z power minus n. N is equal to minus infinity to plus infinity. I was just multiplied z power minus n into the brackets. Now if you want u of n to be removed, we will change the limits to n is equal to 0 to infinity, because it exists for those values of n. an z power minus n minus, this will be from n is equal to minus infinity to minus 1, this signal bn z power minus n. Okay, so this is what you will get. Now already we know the results of these two, correct? That is, the result will be z divided by z minus a. Whether we need to put a minus or plus here. Here it is subtraction, but what we have from the relations, minus of bn u of minus n minus 1 is plus z divided by z minus b. So we need to put here as a plus z divided by z minus b. Okay, and what is ROC? ROC is z greater than a and z less than b. The meaning here is a is smaller than b. This is also we need to remember. Z is greater than a but less than b. So b is obviously greater than a. So ROC is a ring, say this is Z plane. So this is radius of A. According to our equation, what we have is B is greater than A. This is B, this is A. So let me draw another circle of radius B. ROC is, say Z is, it is greater than A but lesser than B, magnitude of A. Z is greater than A, so it is greater than A but it is lesser than B. So this is ROC. Inside this there is no convergence, outside this B also no convergence. Okay, within A and B, in this region, whatever pole you consider, any value of Z you can give and you will get x of Z. Otherwise you will not get x of Z. Okay, that is the meaning of this graph. Real and imaginary axis. I hope this is clear. You can clearly distinguish between the three. One is one with circle A, that is radius A. Second circle is with radius B, because our Z transform exists for greater than A, lesser than B. We can draw the ROC as an concentric circle. This is our ROC, or region of convergence. Inside this there is no convergence, outside also no convergence. ಅಂದ್ರೆ ಈ A ಮತ್ತೆ B ಮಧ್ಯದಲ್ಲಿ ಯಾವುದೇ ವ್ಯಾಲ್ಯೂ ಇರಬಹುದು. A ಅಂದ್ರೆ say 5, I will say Z is equal to 5 and B 7. So in between 5 and 7, any value you give, you will get x of Z. Beyond 7 also not possible, below 5 also not possible to get the Z transform. Okay, that is what we can conclude from the Z transform of this particular sequence. That is combination of both the signals. One is right sided, another one is left sided. Okay, I hope this is clear. The same thing I have indicated here with your intersection equation here. Z is greater than A, intersection Z is less than B, so which is nothing but this one. Z is greater than A, less than B. That's why this is our ROC. Okay, is there any doubt? Please let me know if you have any doubt till now. No doubt, right? Shall we continue? So next are the properties. Okay, this one we have completed. I have scanned it in otherwise in the reverse order. So here I want to mention one point, that is I have given the notes, this complete printed notes, Xerox in the stores. Please go and collect it tomorrow. Yes, is there any problem? Now coming to the properties of ROC. Here in this particular module, properties of ROC, region of convergence ಗೆ ಒಂದಷ್ಟು ಪ್ರಾಪರ್ಟೀಸ್ ಅಂತ ಇದೆ. Those properties are important for your exam and for understanding this concept first. Okay, then properties of Z transform. So there are two kinds of properties. One is for properties of ROC and properties of Z transform. So first we look at properties of ROC. These are just what you can say list of properties. First one, the ROC cannot contain any poles. So now ಇಲ್ಲಿ ROC draw ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ಈ ROC, if I say this, beyond this value there should not be any pole. Okay, ROC will not contain any poles inside it. Okay, in previous example also, ROC is between A and B. It is greater than A, less than B. It will not include A and B. That's why you can clearly see here ROC does not include any poles, but it can be between two poles. Okay, ಎರಡು ವ್ಯಾಲ್ಯೂ ಮಧ್ಯದಲ್ಲಿ ಇರಬಹುದು, ಆದರೆ ಎರಡು ವ್ಯಾಲ್ಯೂ which make x of z infinity will not be there inside the region of convergence. That is first property. Second property is, if x of n is finite causal sequence, then the ROC is the entire z plane except z is equal to 0. So this you have already seen for an u of n. If you consider this sequence only, you have seen that at right sided sequence. For a right sided sequence, for this sequence also it is valid, but z is equal to a. Okay, so for a right sided sequence you will have a ROC entire z plane except z is equal to 0 at z is equal to 0. This is second property. Next, if x of n is finite non-causal, here we have said that it is causal, here it is a non-causal sequence, then ROC is entire z plane except z is equal to infinite. Non-causal sequence is left-sided sequence. For a left-sided sequence, we have seen that ROC exists for all values of z except z is equal to infinity. Here we have seen for right-sided sequence all of z but not z is equal to 0. Left-sided sequence or non-causal sequence z is equal to infinity ಗೆ x of z ಬರಲ್ಲ, ಬೇರೆ values ಬರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ವಿ. So that is what indicated again here. Okay, all the things whatever we are considering here is finite. Remember that finite values, infinity ಯಾವುದು ಇಲ್ಲ ಈಗ ಇಲ್ಲಿವರೆಗೂ ಡಿಸ್ಕಸ್ ಮಾಡಿರೋ ಪ್ರಾಪರ್ಟೀಸ್ ಅಲ್ಲಿ. Okay, next is, if x of n is finite double-sided sequence, then the ROC is the entire z plane except z is equal to 0 and infinity. This also we have verified with the example. So that is property number 4. Double-sided sequence ಗೆ 0 ಮತ್ತೆ infinity ಬಿಟ್ರೆ ಬೇರೆ ಎಲ್ಲ valuesಗೂ x of z valid ಇರುತ್ತೆ. Then we have fifth property, if x of n is causal infinite length sequence, then ROC is of the form z is greater than r max. This is our z is greater than a ಅಂತ ತಗೊಂಡಿದ್ವಲ್ವಾ ನಾವು. Z is greater than a for an u of n. We have seen this, right? What is this a power n? It is summation from 0 to infinity, right? Infinite sequence. That is what, if x of n is causal means positive sided and infinite length sequence, then magnitude of z is greater than r max. This r max is nothing but maximum radius. Okay, that is a. R max equals to the largest magnitude of any of the poles. ನಮ್ಮ ಹತ್ರ ಒಂದು 10 poles ಇದೆ ಅಂದ್ರೆ 10 ಅಲ್ಲಿ ಯಾವ ಪೋಲ್ಗೆ ಜಾಸ್ತಿ ವ್ಯಾಲ್ಯೂ ಇದೆ ಆ ವ್ಯಾಲ್ಯೂನ ನಾವು ಲಾರ್ಜೆಸ್ಟ್ ಪೋಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. Z will be greater than that. Magnitude of z will be greater than that if you choose, then ROC exists. Okay, so that is what ROC is exterior to the circle, z is equal to r max. Exterior ಅಂದ್ರೆ ಇದು r max ಅಂತಂದ್ರೆ ಈ ರೇಡಿಯಸ್ exterior to this. Okay, this also we have seen. Next is non-causal infinite length sequence. That is our u of minus n minus 1. Just now we have discussed, right? For that, magnitude of z will be lesser than r minimum. So it is the smallest value of pole we are going to consider. Okay, this also we have done already. Then ROC is interior to the circle. Already we have seen that for a left-sided sequence, ROC is inside this circle. Then we have for a two-sided sequence, if x of n is two-sided sequence of infinite duration. First three properties we have seen that finite duration. Next we are looking at infinite duration. So infinite duration sequences ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ Z transform will be from R1 to R2. Earlier we have discussed between A and B, where R1 is smaller than R2. This is shown here. R1 circle, this is R2 circle. So in between these two circles we have our region of convergence. And what is R1 and R2? Our A and B, our A1 and A2, it will be the magnitude of poles. ಅಂದ್ರೆ ಯಾವ ವ್ಯಾಲ್ಯೂ ಎಕ್ಸ್ ಆಫ್ ಝಡ್ ನ ಇನ್ಫೈನೈಟ್ ಮಾಡುತ್ತೆ ಅದನ್ನ ನಾವು ಪೋಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ ವ್ಯಾಲ್ಯೂಸ್ ಎರಡು ವ್ಯಾಲ್ಯೂಗಳ ಮಧ್ಯದಲ್ಲಿ ರೀಜನ್ ಆಫ್ ಕನ್ವರ್ಜೆನ್ಸ್ ಇದೆ ಅಂತ ಅರ್ಥ. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ನಂಬರ್ 8. The ROC of an LTI stable system contains unit circle in the Z plane. So these two properties are very important. Last two properties, this we have not discussed. Property 8 is the ROC of an LTI stable system. Andre LTI andre linear, time invariant and stable. So the system which possesses all these properties, that kind of system contains unit circle in the Z plane. So Z is equal to 1. So ROC will be within this one. If I say ROC is say here 1 by 2 and here it is 1, here it is 2, then it will contain this unit circle. ROC contains this unit circle. If we have given with an LTI stable system, then the ROC region of convergence contains unit circle. Unit circle means circle with radius 1. And finally, the ROC must be a connected region. ROC is connected region means when I draw region of convergence, you can see it is beyond some value. If I take example, it is continuous. It is not like here it is there, again it is somewhere here, or again it is somewhere here. It is entirely after A, whatever the value is there, it is completely occupying those values. ಯಾವ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟರು ಆಗುತ್ತೆ ಎ ಮೇಲೆ. ಯಾವುದಕ್ಕೆ? ರೈಟ್ ಸೈಡೆಡ್ ಸೀಕ್ವೆನ್ಸ್ಗೆ. ಲೆಫ್ಟ್ ಸೈಡೆಡ್ ಸೀಕ್ವೆನ್ಸ್ಗೆ ಕಂಪ್ಲೀಟ್ಲಿ ಇನ್ಸೈಡ್ ಎ. Correct? So it is completely connected, whereas it is not a discrete. Somewhere here some ROC is there, somewhere here some ROC is there. It is not like that. Okay, it is a connected region. Region of convergence is a connected region. Is that clear? I hope you understood the properties of ROC. Please make a different notes for this Z transforms, and whatever portions I cover, copy that in your notebook from the notes or while I am solving. If any doubt you get, you can ask in the class or during this class itself. Fine. How many properties we have for ROC? Yes, any one property if you can name. I am waiting for the reply. Okay, Manoj. Manoj, are you there? Arpita? Yes. Are you people there? Gautam?
Sir.
Yes. Any property you can name. See here it is. The ROC content cannot contain any poles. So there should not be any poles inside the region of convergence. Then for finite causal sequence, finite non-causal sequence, finite double-sided sequence. Then for causal infinite length, non-causal infinite length, and double-sided infinite length. After that we have, for a stable system, ROC must include the unit circle, and another point, ROC must be a connected region. If you remember this, you can write these properties. These are very, very important properties which we use throughout this module. Yes, any questions if you have? Darshan K. Darshan M. Harshita. CS. Harshita CS. Are you there? Maulya. You are there? Okay. Answer attendance. Unsure.
Present, sir.
What did you understand?
Sir, properties.
Okay. Then properties of properties of don't know. Arpita FC.
Present, sir.
Bharat.
Present, sir.
Bhumika. Bhumika D.
Present, sir. Present.
Were present. What was
Yes,
the
sir.
topic we discussed today? Don't know. Harshita.
Present, sir. Present, sir.
Darshan K. Darshan M.
Yes, sir.
Darshan N.
Present, sir.
Darshan SV. Darshan SV. Dhanya.
Present, sir.
Are you able to understand, Danya?
Yes, sir.
What were the topics?
Negative time exponential sequence,
Okay,
then the properties of ROC,
okay,
and double-sided exponential sequence.
okay, good. So these are the topics what we have discussed. Fine. So if you have any doubt, any other student also you can ask. Okay. Meanwhile, I will take the turns. Gautam,
Present, sir.
no problem, right?
No, sir. No, sir.
Shivakumar,
Present, sir.
present. No problem.
Yes, sir.
Any
Plus.
doubt? Harshita,
Present, sir.
Harshita, are you able to understand?
Yes, sir.
Okay. Harshita, yes. Manasa,
Present, sir.
Manjesh, Manjesh. Okay, next. Maulya, Niharika. Okay, Niharika, Nisarga,
Present, sir.
Pavana, Pavana,
Sir.
Purvika. Okay, Purvika.
Present, sir.
Okay, Pradeep, Rachana, Rachana, Rajat,
Yes, sir.
Rajesh, Rajesh, Rashmi.
Present, sir.
Next is after Rashmi, Ritik, Tejas. Okay,
Present, sir.
Tulsi, Tulsi.
Present, sir.
Yes, are you able to understand? Varun,
Yes, sir.
Varun,
Present, sir.
Vikshit,
Yes, sir.
Vinayaka,
Present, sir.
Yogendra,
Yes, sir.
Yogesh,
Yes, sir.
Ashok, Ashok,
Yes, sir.
Dhanit, Kruti.
Present, sir.
Present, sir.
Okay, Manoj, Nagendra,
Present, sir.
Sukit,
Present, sir.
Nagendra, Sukit, Vikas.
Present, sir.
So are you able to understand?
Yes, sir.
Okay. So please solve the problems in a different notebook. Whatever I have given. Notes ಅಲ್ಲಿ ನೋಡ್ಕೊಂಡೆ ಮಾಡಿದ್ರು ಸಾಕು ಇವಾಗ ಅರ್ಥ ಆಗಿರುತ್ತೆ ಬೇರೆದು. Please do that. Thank you. Thank you for joining, guys. See you tomorrow.
Thank you, sir.